This animation is intended to explain the unique construction of Millipore Sigma's Natrix chromatography membrane technology and how it achieves dramatic productivity improvements in downstream purification and can enable simplified approaches to bioprocess architecture. The unique macroporous hydrogel construction of Natrix membranes results in flow characteristics and binding dynamics that bring together the best performance attributes of both modern chromatography resins and membrane adsorbers to achieve an unprecedented level of purification productivity. The functionalized hydrogel and Natrix technology features an extremely high level of available surface area, with high binding group density throughout. The hydrogel also features an interconnected pore structure that allows for extremely high flow rates and low residence times. The large pores can effectively handle proteins as well as larger viruses and DNA. Together, these characteristics enable a new, elevated level of purification productivity. Natrix technology also achieves the same levels of selectivity and specificity achieved with modern chromatography resins. To understand how our Natrix chromatography membranes achieve this powerful performance combination, it is helpful to consider how other purification technologies operate. Resin beads feature an excellent binding capacity, but they rely on slower diffusional flow and extended residence times in order for the solute to access binding groups inside the available pores. As a result, resin columns are often oversized to meet process time requirements. Typical pore size within beads also limits the capacity for larger targets, such as viruses and DNA. Conventional membrane adsorbers, meanwhile, allow fast flow rates, but because they offer limited functionalized surface area, their binding capacity is inherently limited. A proper explanation of how Natrix technology achieves its breakthrough purification productivity begins with the methods used to create the membrane. The skeleton of the membrane shown here is a flexible, reinforcing mesh that provides mechanical strength and durability to the finished membrane. Rather than simply coating the fibers of the mesh substrate, the pre-functionalized hydrogel is polymerized in situ within the mesh scaffold. As the hydrogel cures, a new network of interconnected pores emerges within the voids of the underlying mesh. While the mesh starts with the voids ranging from 10 to 25 microns in size, the newly formed hydrogel fills these voids, creating a new pore structure, typically ranging in size from 0.1 to 1 micron. This new structure defines the composite membrane flow properties and contributes to the Natrix membrane's high protein binding capacities. The hydrogel composition can be readily designed to include a wide variety of ion exchange and affinity chemistries. Because the functional chemistry is integral with the hydrogel, binding sites are omnipresent throughout the finished membrane. And because the composite membrane is created in a single step, the manufacturing process for Natrix membranes is extremely reliable and repeatable. We will now take a closer look at a feed stream flowing through the Natrix membrane. The pore structure creates convective flow channels that envelop the flowing solute with functionalized surface area. The combination of this surface area and the high density of binding groups results in more binding interactions per unit of volume than other purification technologies. This enables Natrix technology to match the dynamic binding capacity of resins in as little as 1 second of residence time, compared to more than a minute for bead-based technologies. With this combination of speed and binding capacity, Natrix membrane devices can be much smaller than their equivalent resin columns. This, in turn, makes single-use per batch Natrix chromatography membranes feasible, practical, and cost-effective. In summary, Millipore Sigma's Natrix chromatography technology enables new possibilities for both individual purification unit operations and overall manufacturing architecture, and is a cornerstone of intensified next-generation processing. Natrix columns achieve the critical purification quality attributes established by reference resin processes, while enabling the following improvements in biologics purification. The improved productivity of Natrix technology enables much smaller single-use plug-and-play columns, making possible smaller and flexible facilities. The versatility of Natrix membrane technology enables future Protein A and other affinity versions. These products promise to unlock fully single-use monoclonal antibody manufacturing and process intensification. With the Natrix membrane platform, the productive purification of monoclonal antibodies, viruses, and other challenging biologics is possible. For more information on our Natrix chromatography membranes, please visit the website shown here.